Welcome to the deep dive. We're here to really extract the key insights from your sources. And today we are diving deep, really deep, into something, well, fundamental for anyone interested in decentralized tech, especially if you follow the blockchain world. Your source material today, it's titled Ethereum Scaling Solutions Explained. Okay, let's unpack this because, that title alone, Ethereum Scaling Solutions Explained, it's more than just a technical phrase. It tells a story, doesn't it, about a system that's kind of dealing with its own success. And it points right at one of the biggest challenges and, frankly, opportunities for the whole decentralized web.
What's fascinating here is exactly that. The very need for something called scaling solutions for Ethereum. It signals, well, a certain maturity and ambition. It's not just about making something work anymore. It's about making it thrive, under potentially huge demand. It suggests a recognition that the original design, brilliant as it was, wasn't quite ready for the sheer volume we're seeing or hoping to see. It really highlights that core tension in blockchain, doesn't it? That constant balancing act. You've got decentralization, security, and then you need efficiency. Throughput. We often talk about the scalability trilemma here. It's hard to maximize all three at once.
That's a perfect frame, the scalability trilemma. So, for you listening, when you see Ethereum Scaling Solutions Explained, it's not some dry technical manual, not really. It's actually the core of how Ethereum plans to grow up, essentially, to move beyond where it is now. It says, yes, the network's popular, it's working, but that very success creates, well, growing pains. It feels like we're shifting from a sort of proof of concept phase to building real infrastructure for potentially, well, everyone. And that needs architectural changes, deep ones.
Absolutely. And if we connect this to the bigger picture, scaling is essential for any technology aiming for mass adoption. Think about the early internet. It wasn't built for Netflix, right? Or global shopping. It had to evolve. It scaled through layers and layers of new ideas. But blockchain scaling, it's uniquely tricky. Because we're not just trying to build, say, faster highways. We're trying to build faster highways where every single car checks every other car's journey, and crucially, there's no central authority directing traffic. So the solutions part, it's not just about speed, not just raw capacity. It's about how you boost that throughput, make things more efficient, while holding on to those core values. Decentralization, security, censorship resistance. You lose those, and well, what's the point? It wouldn't be blockchain anymore. So the source isn't just explaining what to do, it's implicitly about how to do it right, without compromising the foundation.
That's such a critical distinction. It's not just tech, it's almost ideological too. So thinking about you, our listener, maybe you're building on Ethereum, maybe you're just using it. What does this constant need for scaling solutions actually mean day to day? It's got to be more than just hoping for faster transactions, right? It implies the network's capabilities are always under review, always expanding. For developers, maybe that means new tools, different environments to build in. For users, maybe new kinds of apps become possible. Or costs might eventually come down. Network reliability improves. It feels like it's about broadening the horizon of what Ethereum can realistically achieve.
Precisely. Yeah, the push for scaling solutions isn't some, temporary fix. It's a continuous effort, multifaceted. The whole ecosystem is involved.
Yeah.
It's fundamentally about ensuring that as this technology matures, particularly Ethereum, it can actually function as a global settlement layer, a high throughput one, for all sorts of decentralized applications. And this raises a really important question. How do you encourage rapid innovation, sometimes really experimental stuff, radical new ideas, while still protecting the integrity, the security of this massive distributed system holding, billions in value? That balancing act, that defines the whole scaling conversation. It's really about designing for a future that we can't even fully picture yet, but we know will demand much, much more from the network.
Okay, let's focus on that word explained from the source title. Ethereum Scaling Solutions Explained. Okay. Why is the explanation so important? Why highlight that? For an informed audience, like the people listening to us, it's not just about knowing these solutions exist. It's about understanding the trade-offs.
Right.
Or the different paths being taken. It suggests the community is wrestling with complex choices. There's an ongoing story here. It speaks to the sheer complexity and maybe the need for everyone to get on the same page, have a shared understanding to navigate what's coming. Because it's often misunderstood, isn't it? There's no single scale now button.
No.
It's more like a whole menu of different conceptual approaches, each with pros and cons.
You've absolutely nailed a critical point there. Clarity is vital because understanding these solutions informs major decisions for everyone. Developers need to know, do I build right on the main chain or use a layer 2? And if it's a layer 2, which kind? They all have different properties, different assumptions. For users, too, it affects how you think about transaction costs, how quickly your transaction is final, even the security guarantees you're getting depending on where you operate. So when these things are explained well, it builds confidence. It allows people to participate more intelligently. It aligns the community around the network's roadmap. It's really about demystifying what could otherwise be just a confusing mess of tech options, translating it into understandable choices, understandable trade-offs.
Maybe an analogy helps here. Let's try one maybe a bit richer than just city traffic. Imagine a city, a global open source city. Everyone kind of owns a piece of the infrastructure, the roads, the power lines, everything. And there's no single mayor, no central planning department. Decisions need broad agreement, consensus, and everyone wants the city to be secure, fair, open. Now, the city gets popular. More people move in. More complex businesses start operating. And the original main rows, it's like the main Ethereum blockchain, the layer 1, they start getting really clogged, expensive to use, slow.
Right. Classic growing pains.
Exactly. So the community, the citizens, they need scaling solutions. But they can't just decide overnight to bulldoze and build massive new highways through the city center because changing that core infrastructure is incredibly hard, risky, needs massive agreement. So some citizens propose upgrades within the existing city structure, maybe optimizing traffic lights, adding dedicated bus lanes, maybe even conceptualizing dividing the city into interconnected districts that manage local traffic but stay under the same city charter. These are kind of like your layer 1 scaling improvements, things like sharding, conceptually. Fundamental upgrades to the main city itself.
That's a great way to picture the layer 1 approach, improving the base layer itself, making the original city more efficient from within. But crucially, others might say, hold on, let's try something else.
They might propose building, say, specialized industrial parks or super fast commuter rail lines just outside the main city, but directly connected to it. These handle huge amounts of daily activity commerce commuting off the main city roads. These are your layer 2 scaling solutions. They don't rebuild the main city center, but they massively extend its overall capacity. How? Well, they process tons of transactions off the main blockchain. And then, periodically, they bundle everything up and send a kind of compressed summary or a proof back to the main Ethereum chain for final recording. Think of it like those specialized hubs handling massive volume locally, then just sending a single verified summary report back to the main city archive.
Okay, so layer 2, conceptually, that's a pretty different way of thinking about handling transactions. And even within that layer 2 idea, the different flavors, different architectures, right? Like you hear about optimistic rollups. What's the concept there?
Conceptually, it's like saying, okay, this adjacent hub, this rail line, we'll assume all the activity happening on it is legitimate.
No.
But, crucially, we leave a window of time, a challenge period, where anyone watching can cry foul if they spot fraud and prove it.
Exactly.
So it's like a high-speed system that generally trusts its operators, but has a robust mechanism for catching errors after the fact.
Fast.
But with a delayed finality? Sort of.
Precisely. It's optimistic because it assumes transactions are valid unless proven otherwise. Now contrast that with ZK rollups, zero-knowledge rollups. These take a fundamentally different approach, conceptually. Instead of assume valid, challenge later, ZK rollups use some pretty advanced cryptography zero-knowledge proofs to actually prove the validity of a whole batch of transactions before that summary ever gets sent back to the main Ethereum chain. So going back to the analogy, it's like having an incorruptible cryptographic auditor instantly verify every single package leaving that specialized hub before it's even logged in the main city records. This gives you, theoretically, much faster finality and security guarantees that derive directly from the main chain security, the trade-off. Often it's computationally more intensive, more complex to generate those proofs, but the security model is different, stronger immediate assurance. So the source, just by saying scaling solutions, it implies this whole landscape of different strategies, different ways to get more capacity.
Yeah, that breakdown really helps clarify things. It's not just about faster. It's about architectural choices, different paths. And these layer 1 and layer 2 approaches, they obviously come with their own trade-offs. That's key for anyone trying to understand this space. Layer 1 upgrades, like sharding, the goal is often boosting the base layer's own capacity, more room on the main roads, more data availability. But, as you said, These are huge undertakings, years in the making. They touch the core protocol, need that broad consensus, very complex.
Yeah, a significant point. Layer 1 scaling, it aims for those fundamental improvements, but it's often a much longer, more difficult journey. You have to be incredibly careful not to break security or decentralization at that base level. Layer 2s, on the other hand, because they kind of sit on top of Ethereum, they can often be deployed faster, offer more flexibility maybe, but they bring new things to think about. Users need to actively move assets, bridge them onto these layer 2s. Developers need to learn the specifics of each L2. Is it optimistic? Is it ZK? What's its dispute process like? How fast is finality? What tools are available? So the solution isn't one thing. It's really a whole ecosystem of tools emerging, and each one is kind of optimizing for different points on that scalability trilemma triangle. Some push for speed, some for low cost, some for specific types of applications.
So when our source says Ethereum Scaling Solutions Explained, it's really explaining a landscape of strategic choices, not just one magic fix. And this whole ongoing effort, it's not just about shaving milliseconds off transaction times or saving a few cents on gas fees. It's not in isolation. It feels much bigger. It's about pushing the limits of what this whole idea of a decentralized, programmable internet can actually do.
Exactly.
It's really a sign of how dynamic this technology is, constantly evolving, adapting to its own growth, pushing for more utility.
It's about building a foundation that can actually support the future that people envision for it.
And that, I think, brings our deep dive for today towards a close. We've really tried to explore the core concept, the fundamental importance of Ethereum scaling solutions, using your source as our guide. We've dug into the why. Why are these solutions needed? Understanding it's a natural, almost inevitable part of success for any growing platform, but with unique twists in the decentralized world.
Right. And even if you don't get into the absolute technical weeds of every single project, just understanding that scaling involves this whole landscape of different conceptual paths. Layer 1 upgrades versus layer 2s, and within L2s, the different ideas like optimistic or ZK rollups. Grasping that conceptual map is absolutely key. It helps you appreciate where Ethereum is likely headed. It shows the network isn't static. It's actively innovating, wrestling with those tough trade-offs we talked about, evolving to be hopefully more robust, more efficient, more useful for more people. Understanding these concepts, the choices they represent, that's a critical piece of the puzzle if you really want to get a handle on decentralized tech and its potential.
So here's a final thought to leave you with. As you continue to watch or participate in this decentralized space, what other big fundamental challenges do you see shaping development? And thinking about what we discussed today, how might understanding their specific scaling solutions, the diverse approaches, the inherent trade-offs change how you view things, or even the decisions you make in this incredibly fast-moving field?